Welcome to Module 4's Python lesson. I'm Professor Seth Frey, and today we're going to learn about collections of things in Python. To date, we've learned about lots of different kinds of things in Python, the idea of true and false. We've learned how to do a bunch of things with text represented as strings of characters. We've learned to change and compare and otherwise manipulate lots of other things. So from that foundation, we're going to build up a little further. We're going to learn how to make lists of things. We're going to learn how to access those lists, to pull the things out of them, our little collections. We're going to learn to change and grow lists, to transform lists. We're also going to see that strings sort of are our lists. We're going to learn to generalize the concepts of things that make a list and apply those to strings and really see a lot of parallels between strings and lists. We're going to start by running our boilerplate code, our little code block, and then we'll get into what a list is. So the syntax for a list is use a square bracket, look around for your keyboard on where the square bracket is, and then you put an item in the list and you separate all the items in the list by commas. So this list, my sublist, this list which is being assigned to the variable my sublist has three elements. It has the string A, it has the string B, and it has the string C. And if we run this, we'll see that my list's value is a list of three elements, A, B, and C. What's the type of my list? We check its type, and it's this new type of thing. It's a list. It's a type of collection. We can put other kinds of things in lists. We can put numbers in lists. So our list, they can contain duplicates. This list contains 1, 2, and 3, but a bunch of other ones as well. So it has 5 elements, 3 of which are 1. It can contain, lists can contain a mix of things. This version of my list, we overwrote the old my list. Now we have a new my list. This my list has the number 1, the string 1, the string high, the value true, and then the decimal or float number, 100.5. And it has all those things in it. It's a list of 5 things. It's 5 long. We can put other things in the list. This list has 2 commas, the string 4, and then the sum of 3 plus 5, whatever that is. Python's not going to keep that expression. It's going to process that expression and give us the output of it. So processing still happens in lists, but once we get a sort of primitive basic element that Python can't do anything more to, that's going to be the element of the list. Now, variables are where we store things, and because we can store all kinds of things in a variable, we can store all kinds of variables in a list. This code block is defining the days of the month of lots of holidays that occur in December, and now we're going to define a variable called December holidays composed of those numbers. When I print out December holidays, I'm not going to get Xmas and the beginning of Hanukkah and end of Hanukkah and New Year's and Black Friday. I'm going to get the numbers 25, 10, 18, 31, and -3, because Black Friday is actually in November. We can have a list that has just one thing in it. This is a tiny list. I have a variable called list that is tiny. It's been assigned square bracket 9 close bracket. There's no commas because there's only one thing. There's nothing to separate. And when I print out list that's tiny, I'm going to get the same list back. And when I print the length of that list, just like we could get the length of strings, we can get the length of a list. I'm going to get the number 1 because it only has one thing in it. A list can also have no things in it. If I do open close square brackets, I have the empty list. The length of that list is 0. That doesn't seem like it'd be useful right now, but 0, when you first learned about 0, didn't think it'd be useful. 0 is the idea of nothing, and the idea of nothing is valuable in other types of things. The empty list is going to be something that we go to a lot. Now that you have the basics of how to define and how to define a list and see its length, well, try your luck, make sure you understand things, and we'll move along. Having learned how to put together a list, we can now look how to go inside of a list. There's not much point in building a collection of things if you can't go through it later and pick out the things you want. So we'll get our introduction to the syntax. Just like, this is going to be funny, we use syntax, we use the square brackets to define lists. We're also going to use them to look inside lists, to find the syntax we use to look inside of a list. So this first line defines a list called highways. I live near 80 and 113 and 99 and 5 and 505. Okay, and so when I print out highways, I'm going to get that list back. But when I print out highways, square brackets, 0, close brackets, that's how I tell Python I want the first thing in the list. Why 0 instead of 1? It's called zero indexing. It's some jargon. The basic idea is, all you need to know is the first thing in the list is at address 0. The thing at address 0 in highways is 80. The thing at address 1 is 113. Address 2, address 3, address 4. The addresses start from 0. It's just something you have to know, something you have to get used to. So the thing at address 0 is 80. I'm going to print out 80. I'm going to print out the thing after 80, 113, print out 50, then I'm going to skip and print out the thing at address 5. This is a list of 6 things, and its last thing is at address 5. So I should get, for my last line of output, 505 when I run this code. And that's what I get. I get the list, I get the first thing, I get a couple other things, and I get the last thing. That's good. And just like we can print out variables, we can and treat variables like numbers and arithmetic expressions, we can treat the values the results of querying or indexing a list. That's what the second square brackets, that's what we call it, looking inside of a list. We can multiply that by 2. So the thing at address 1 is 113 up here. So Python's going to see this, and it's just going to replace all this with the number 113. And then it's going to replace all that with 2 times 113, which is 226. So when I run this code, I should get 226, and that's what I get. Okay, so that was all new. Now we have something else new. Just as we're getting used to this weird double square, 2 meanings of square bracket thing, now I'm saying -1. What's the thing at address -1 in the list? Well, this is a little cute. Python, it's common in any language to want to access the last thing in the list, but you don't know if your list is 5 long or 100 long. You want to access the list without having to care about how long the list is. So Python kind of lets you start backwards. Highways -1, the square brackets -1, refers to the last thing in the list, wherever that last thing is, whatever its address is. So when I run this, I should get 505, the last thing in the list. You can actually keep going. You can get the second to last thing in the list. -2, that should give me 5, highway 5. And that's what it gives me, which is just fine. So this is something actually you'll use fairly common. It's going to be useful to you in the future to be able to access the last thing in the list as easily as you've been able to access the first thing in the list. So I told you there's 2 uses of square bracket. One's to define what a list is. Another's to help us look inside of a list or define what it means to look inside of a list. But you haven't been confronted with how ugly that is, how scary or weird that is. Because what I did was I defined a list, put it into a variable, and then index that variable. So you never saw both kinds of square bracket on one line. And normally you won't, but I'm going to show you what that looks like. This is going to be pretty ugly. What we've got here is precisely that. This looks like it shouldn't mean anything. Before I told you anything about square brackets or commas or lists, you would have seen this code and thought, that's the most unreadable, meaningless jargon I've ever seen. But now, you know the rules that Python follows, and you can start to follow those rules in your own head. So you know that the first set of square brackets is going to define a list. And it looks like a list definition. It's got commas. It's at the front of the line. It's got a bunch of stuff in it. Great. So this is a list. So what's this a list of? This is a list of the number of days in every month of the year. So it's 12 long. That's a list. And then these square brackets following that list are indexing the first list. They're not another list. Why? Because those square brackets follow a list. And so Python knows their indexes. Now, again, that's technical. That's following Python's rules. That's what's going on. and you don't have to be totally exposed to what's going on for the same reason that you don't know how to fix your car. You know how to drive your car. So we're going to keep things at a high level. You don't have to know every identity of every part of your car to drive your car. And for the same reason, I'm showing you a little bit under the hood. I'm showing you sort of the complexity that's usually hidden away because we use variables to make things more friendly and more usable. But this is what you're facing. We're looking, what this code does is asking for the thing at address 10 in this list. What's the thing at address 10? We start from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the second to last item in the list. That's November. The number of days in November is 30. I run this, I should get 30 days. Now we're going to give you a chance to get comfortable with following Python's rules and indexing and creating lists. Having learned how to create, having learned about this new type of thing in Python, we're going to learn new types of errors. So if I define my list as 1, 2, 3, but I try to index the thing at address 5, well, there is no thing at address 5. Python's not going to know what I'm talking about, so I'm going to get an error. If we run this code, I should get precisely that. I should get an error. Oh, that's ugly. List index out of range. That's pretty straightforward. The list has a set of addresses. My index was one of those, was supposed to tie or match up to one of those addresses, and it didn't. The index I put in was outside the range of available addresses. That's what that means. So if you see that error message, it means the thing you tried to get was at an address that doesn't exist in the list. We're learning a little bit how to speak Python, how to think in Python. I'm going to delete this code because we do not want to leave error-prone code in notebooks that we submit for credit because we'll only get partial credit. I'll give you a chance to try that out before we move along to the next to the next section. We've learned how to pull one thing out of a list, but we can also pull several things out of a list. We can pull a sub-list out of a list. Instead of getting one item from a list, we can get sort of stretches from a list. We're going to call that, our jargon for that, the thing to Google for when you're stuck on it or trying to learn more about it, is slicing. List slicing in Python. There's a syntax for that, so we're going to find the even numbers here, and here's my syntax. I have my square brackets. This is indexing because it's square brackets after a list. But instead of putting a single number, I put a number, and then I put a colon, and then I put another number. And what that means is I'm getting the thing from the 0th address, until, but not including, the thing at address 3. Now, why up to but not including? It's just one of those things you have to memorize. You have to remember. It's sort of elegant eventually once you're comfortable with it, but until then you just have to remember it. We're getting this stuff from 0, including 0, up to 3, but not including 3. So let's look at what that is. We're getting the thing at address 0 is 2, the thing at address 1, the thing at address 2, but not the thing at address 3. So this first command should give me 2, 4, and 6. The second command is going to give me the thing at address 3, up to, but not including, the thing at address 6. The thing at address 3 is 8. Let's see, 1, 3. 4 is 10. 5 is 12. But not the thing at address 6, not 14. This next thing is going to give me the last 3 characters. It'll give me 14, 16, and 18. And this very last command, it wants the thing at address 1 up to but not including the thing at address 2. So what's that? The thing at address 1, well, that's 0. So it's the thing at address 1 is 4. The thing at address 2 is 6, which we don't want to include. Up to but not including 2. So this last command should give us a list with just one thing in it. I run this command, and that's what I'm going to get. Just like I expected, I got the first 3 things, the second 3 things, the third 3 things, and my last output was a single number, a list with a single value, a list of length 1. There's some extensions to the slicing notation that just make it a little more easy to work with, a little less readable, but certainly more flexible. So our first code to get the first 3 items of the list, this is just a repeat of those lines. I want the first 3 items, everything from 0 to 3. Well, you can actually leave out the 0, and Python's going to know if you have a colon without a number before it, it's just going to give you everything from the beginning of the list until, but not including, your second number. That's this. Or you can leave out the thing after the colon. What that's going to do is it's going to give you everything from and including the thing at address 3 until the end of the list, however long the list is. You can even leave out both the number before and after the colon and just put a colon there. What's that going to do? It's going to give you everything from the beginning of the list to the end of the list, which is actually the same as just printing the list out. So if I take that line, copy it, and just get rid of the indexes, the last 2 lines of output are going to be identical. So let's go through our output one by one. This is the first 3 elements of this list, even numbers. They're the result of this first slicing. That's good. The second line of output's identical because this syntax is identical to this syntax. We just left out the 0, which is fine. 0 was the thing at address at address 0. It was the first thing in the list. So this slice starts from the first part of the list. This slice starts from the thing at address 3 and just continues to the end. It should be a longer slice, and that's what we get. This third output proceeds from the thing at address 3 to the end of the list. And then these last 2 lines of output, they're just giving me the whole list. One, because I just printed out the whole list. The other, because I printed out a list, I printed all elements from the first until the last. It's sort of redundant, but it's an expression of the versatility and available from the slicing syntax. This ability to take a big list, but you only want part of it. You use slicing to do that. There is a gotcha with slicing. Slicing and indexing are different. Indexing always returns a number, or returns the thing at that address. Slicing always returns a list of things at that address. So you end up with the difference between a thing and a list containing nothing but that thing. So to index the thing at address 0 of this list, well, that's to pull out the number 1. To index the slice of everything from 0 up to but not including 1, that's also going to give me 1, but it's not going to give me the number 1. It's going to give me a list containing the number 1. So my types are going to be different. There I got 1, there I got number 1. Those are different. Those are not, if I was to ask if those are equal to each other, the answer would be no. And you can see that because they're different kinds of things. The output of the first is a number, the output of the second is a list. It happens that the list only contains that number, but those are still different things. This is a subtle point. It's just one of those things you have to know. A lot of Python is going to be intuitive, just roll off the tongue. You can take a string, multiply it by 3, and you get 3 times the string. That feels good and intuitive. Other parts are going to feel a little rougher when you first get to know them. And this is one of those things you just have to get used to. You're going to make that mistake, and you'll keep making it until you learn to stop making it. And that's just sort of part of it. Part of the learning curve is getting used to these little tricks, little gotchas, little subtleties. And as part of the nuance of learning to think and code, this new way of thinking that's valuable for you, that makes you a bigger person. So, don't just take my word for it. Try things out and make sure you understand it. Go through the exercises and see how you do. Having learned how to define lists and look inside them, index and slice them, now we're going to look at how we can change them, how we can take one list that's close to what we want or related to what we want and turn it into a list that we do want. So we'll start with a definition of my list, the list 1, 2, 3, 4. We're going to print it out, so our first line of output will just be the list that we just created. Then we're going to do our standard indexing syntax. That list, square brackets, the thing at address 2. What's the thing at address 2? Here's the thing at address 0. Here's the thing at address 1. So here's the thing at address 2. It's the number 3. We're gonna take whatever, we're gonna say whatever used to be at address 2, we want to replace it with this new thing. This is just like defining a variable, but now instead of overwriting a variable, we're overwriting a position in the list. And so my new list should say 1, 2, new value, the string new value, and then 4. Let's run it. Okay, that's what happened. So we successfully overwrote an entry in the list. We can begin to change the list. Why is this useful? Here's a quick little example. I came up with the President number 44's cabinet. The first element of this list, the thing at address 0, is going to be the Secretary of State. Then we have the original, the first founding Secretary of Treasury. Then we have the Secretary of Defense. Then we have the Attorney General. So when President 44 began his term, these were his 4 cabinet members in those positions. That was the cabinet in 2008, and our first output is going to be that list. But then, at some point during the 8 years of that presidency, we see that the thing it addressed to, who's that? 0, Secretary of State. 1, Secretary of Treasury. 2, Robert Gates. Robert Gates, Secretary of Defense, got replaced with Leon Panetta. And then, shortly thereafter, we got another Secretary of Defense, Chuck Hagel. Then we got a new Secretary of State. Then we got, who's it address 1? Is Timothy Geithner, that Secretary of Treasury. Then we got a new Secretary of Treasury. Then we got another Secretary of Defense. So we've gone through 3 Secretaries of Defense. Then at the very end, we got a new Attorney General. And so having made all these changes to the cabinet, the last line is going to print the new variable cabinet sub 44 with all of its new values. Let's see, what do we have? We've got, we sure went through a lot of Secretaries of Defense. We started with Robert Gates. We ended up with Ashton Carter. Nowhere in this final list that we ended up with do we see Leon Panetta or Chuck Hagel. They both overwrote the previous Secretary of Defense, but then got overwritten before anything got printed out. So they don't appear in the output because we never printed out the list when it had those values in those positions. We get the beginning, we get the end. So in this case, we're using overwriting. We're using this assignment to a list index to represent a process over time and to compare how it began to how it ended. And what we can see is that there is complete turnover in these 4 cabinet positions over 8 years of the presidency. So you can play around yourself with indexing and assigning to an index, and we'll move along. In addition to changing things, changing positions or indices within a list, we can also grow a list out. The first we'll use is append, a function called append. So frankenlist is the numbers 1 through 4, but we're going to append B to it and print it out. What we should get is a list with 5 things in it, 1 through 4, and then the 5th element will be B. When we append C again to it, we'll end up with a list that's 6 long. And here we are. We extended the list, or we appended things to the end of the list. Separate from appending lists, that's when you want to add individual items to the end of a list. You can also add whole lists to the end of a list. Rather than append, which takes an item, we're going to extend, which takes a list. We'll extend frankenlist by 3 more items. So we have 1, 2, 3, 4, B, C, and then we're going to get X, Y, Z at the end of that. I run it, 1, 2, 3, 4, B, C, X, Y, Z. We took, X, Y, Z was a list, and we extended the old list by those 3 more elements. We can also further extend frankenlist by itself. We're just sort of playing around. We're going to take elements 5 through 7 of frankenlist. What are elements 5 through 7? Well, here's 0, 1, 2, 3, 4, 5. So we're going to start at C. 5, 6, 7, not including 7. So what Python's going to do when it sees Franklin list 5.7 is it's going to just replace that with this sublist. CX, and it's going to extend Franken list by those two elements. So what we should get is 1, 2, 3, 4, BC, XYZ, CX. So let's see if we get that. There it is, CX at the end, just like we expected, because we simulated what we think Python is going to do, step by step, very methodical. To give you, so we, in addition to adding things to the end of the list, we can also, in addition to adding things at the end of the list, in addition to overwriting things in the middle of the list, we can also insert things in the middle of the list. That is, go in the middle of the list, pull it apart, and put a new thing in there, which is different than going to a list, picking one thing in the middle, and replacing it. And we use the insert function to do that. So we have places, first, third, fourth, and sixth place. Maybe these are medals or positions in a race. We're going to go into position 0. So insert takes two arguments. It takes the address that we want to insert into, and it takes the thing we want to insert into that address. So into position 0 of places, I want to put the string 1st. And then into position 4, the new position 4. So we're going to have 1st, that's the position 0. We're going to have second, third, fourth. So the thing at position 4, we're going to insert between 4 and 6, the number 5th. We run it, we started with second, third, fourth, and sixth. We ended up with first, second, third, fourth, fifth, and sixth. We inserted twice. You can see that the fourth position for fifth, that's not the fourth position of this 0, 1, 2, 3, and then we didn't add fifth after sixth because we didn't insert it into the original places. We inserted it into places that had already been changed by the addition of first. So we added to the fourth position of this 0 of the second line 0, 1, 2, 3, 4. We're finding the fourth position and we're inserting into that. And just a little FYI, I always have to remind you about outputs, how outputs work. That not every command has an output, and that's important because sometimes you do a thing and you sort of expect to see the result of what you did, but Python's not always going to show you. You have to use print explicitly to sometimes find out what you did. We don't get output when we assign using equals. We've learned that before. We also don't get output when we use append or extend or insert. We have to separately print out. So when I append 4 to the end of 1, 2, 3, I don't get any output. I just get that. Usually I get an output. What I have to do if I want output is follow that exact same code with a printing out of the thing that I want to look inside. There, I got my 1, 2, 3, 4 just like I wanted, but I had to be explicit. So having played around with insert, append, and extend, you can now try it on your own and make sure you understand it. So we've learned quite a few things about lists, how to create them, how to look inside them, how to change them. We do want to give a little moment to the empty list. This is the list with nothing in it. Again, it doesn't seem like it'd be useful, but it turns out to be useful. Here's the empty list. Here's how long it is. It's of length 0. If we extend a list by the empty list, it won't get longer. We're going to add the empty list to this list, and we'll see that it's the same length as the original. But what's valuable about the empty list is we can use it as a starting place, as a building block. So it's been a couple weeks since I went. I'm looking in my fridge, and my eggs are all gone. My shopping list is empty, but I'm going to add eggs to my shopping list. I go back the next day, I see that both sugar and milk are low, so I'm going to extend that same list by sugar and milk. The next day I'm out of ramen, next day I'm out of juice. after all these incremental additions, starting with an empty shopping list, I end up with a long shopping list of 4 things. Then my vegan roommate comes along and says, no, you can't get eggs, you can't get milk. So I use assignment over indexing to replace the eggs with egg substitute, to replace the milk with almond milk. So what I should get at the very end is the shopping list of the following. I'm simulating, I'm practicing in my head. Egg substitute will be the first thing, then sugar, then almond milk, then ramen, then juice. Is that what we get? Egg substitute, sugar, almond milk, ramen, juice. Very nice. So now you can play around with growing lists from the empty list yourself. So having learned all this about lists, we can actually go back to strings now and bring the lens of list thinking to strings. I've already explained that Python represents text as a string of characters. So it's not the same as a list of characters, but it's sort of comparable. They're kind of the same. Strings are pretty much lists, but where lists can have all kinds of things, strings can only have one kind of thing. They can only have characters. Before we were able to add strings, we can also add lists to each other, the same kind of addition. The original Star Wars trilogy plus the prequel gives us the first 6, gives us a single list that's 6 long of the first 6 movies. The affirmation, I'm going to have a good day not, just like I can do string operation of adding different strings to produce a bigger string, just like I can do that on lists, add lists to produce a bigger list, I can also take a thing I learned about lists. I learned that I can index and slice lists. You can also index and slice strings. So taking this string, I'm going to have a good day not, the 0th element, the first line of output of this block is going to be I, the first character. The second line of output is going to be everything from I, 0, 1, 2. It's going to be I space A. That's going to be the second line of output, not including M, which is the thing at address 3. 0 to 29, I don't want to count it out, but that's going to go to a certain point in the list. An affirmation, that's going to go from the 14th to but not including the 29th. And that's going to turn into a string. Then we're going to add to the end of that string an exclamation point. That'll be our last line of this output when I run the code. And it turns out everything from 14 to 29 is the string, have a good day. And I essentially left out the comma space not and replaced it with an exclamation point to wish you a nice day. Just like there's an empty list, there's an empty string. It's of length 0, like we're used to. Just like we can check for things in strings, we can check for substrings and strings, we can check for things in lists. Here's a list of all the states. I want to know, is Illinois one of the states? Is Washington, D.C. one of the states? Illinois, I see it. Washington, D.C., I do not see it. So I should get true and false. That's what I get. I have a list of prime numbers here. Here's a prime, is the prime 11. Here's a number that's not a prime, is 12. Is some prime, is the 11 in the primes? It should be. Is 12 in the primes? It shouldn't be. So I should get true and false when I run this code. True and false. Now, just like you might check for one thing in a list, you might want to know several things in a list. That's not always meaningful. But let's say I have a list of all the ages of everyone in my class, and I want to know how many people in my class are 18. I could do 18 in list. And if I got true back, that would tell me at least one person in my class is 18. But that wasn't my question. My question was, how many 18-year-olds are in my class? So there's a new function, there's a function called count you can use. You do ages.count, and you can use this on lists, you can use this on strings. In the case of lists, I'm going to count the 21-year-olds in this list, and I see 3, so I should get the number 3. How many 16-year-olds do I see in the list of ages? I don't see any 16-year-olds, so I should get 0. I can use it on strings as well. Mississippi.countI tells me how many I's are in Mississippi. Looks like 4. And that's what we get, 4. This metaphor is so strong between strings and lists that you actually can turn a string into a list fairly easily. What we're going to do is take the string, put it inside this function called list, and that'll turn the string into a list of characters. So my first line of output says that Harold mod, the variable of the string Harold mod is a string. That's my first line of output, my first output. My second output is going to turn this string into a list, and that's what my second line of output is. It's the string, the character H, the character A, the character R, and so on, so on, so on, with a couple spaces to the end. And then what type of thing is this? It's a list. So that's what my last line of output says. Okay, so play around a bit with this metaphor, with this tie, with this link between strings and lists before you continue. So we've learned to do lots of things with lists, but now we're going to learn a couple more. You can also summarize lists. You can turn a whole list into just one number. Maybe it's length. Maybe it's sum. Maybe it's maximum or minimum value. That's a common thing to do. The word statistic means to take a bunch of numbers and turn them into one number. It doesn't have to be the mean or the median. It could be any number. So each of these functions takes a list of whatever length and turns it into one number. Length turns it into its length. So 0, 1, 2, 3, 4. Let's see. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should get 9 as our first value. The sum, I don't want to calculate the sum on the fly, but it's going to be all these numbers added together. The max, what's the biggest number here? It looks like 37 to me. And the smallest number, that looks to me like, I think 18 is the smallest number. So I should get 37 is 8 and 18 is my last two lines of output. 37, 18. 213 was that sum. I'm glad that's what programming and code is great for, is doing sums that we don't want to do. We can do the same thing. So these are the different sizes of coffee you can get at the coffee shop. How many different sizes of coffee can you get? If I ordered one of each, how many ounces of coffee would I drink in total? What's the biggest coffee I can get? What's the smallest coffee I can get? We can get all these answers by summarizing the list down to these different statistics, down to these different numbers. In addition to reducing a list down to one number, we can also rearrange lists. That's a useful thing to do. I might want to sort a bunch of people by height. These are a bunch of police codes that I can put in a different order. So the first one used to be 04. The last one used to be 36. Now the first one's 36 and the last one's 04. Why do we do that? So we certainly wouldn't do it for police codes. I don't know why I did that. But there's other reasons to reverse a list. There's this other ugly syntax for reversing a list. That looks really ugly. We have the list, and we have open bracket, colon, -1, close bracket. I could explain why. I'm not going to explain why. You're going to see this sometimes. It is shorter than typing out the word reversed, but putting that syntax at the end of a list literally does the same thing. It reverses the list. It works the same way. Why did I just get my original list back? I thought, Seth, you just said I reversed it. But look, they're the same. That's because I defined the list, then I reversed it, then I showed the reverse of the reversed list. I reconstructed the list. If I run this code again, if I reverse it again, if I reverse it twice, for simplicity, I'm going to comment this out, run this. So I have my original list. The reverse of this list is going to be an actually reversed list. 36 at the beginning, right? At the beginning, and 10-4 at the end. So you can reverse a list, you can sort a list. If you have a bunch of items that are out of order, you can put them in order, and you can put them in reverse order. So in my original list, 1077 was was not at the end, even though that looks like the biggest number. When I sort it, 1077 goes proper to its proper place at the end of the list. When I sort with reverse equals true, so sort's a function, it has parentheses, I can put things in the parentheses. One of the things I can put in the parentheses of the sort function is reverse equals false, which is the default, or reverse equals true. If I put reverse equals true, my 1077 goes to the beginning, and my smallest order was a 10-1, which used to be at address 2, but becomes the very last thing in the list. So we can reverse lists, we can sort lists. And just like append and extend and insert, sort and reverse don't have an output. So if I wanted to see what their values are, I have to print it out explicitly afterwards. So having learned all these things about lists, how to create them and change them, now we're going to ask, is there anything useful we can do with this collection of list tools? What can we do or learn about it? And what I'm going to do with it, what our little demo, what our bringing it all together is going to be, I'm going to take you through the history of our calendar, of the Western calendar, what's called the Julian calendar. We've got 12 months. They have different numbers of days. There used to be different numbers of months. They used to have different numbers of days. Let's go step by step through it. We're going to start off with the original calendar. The original calendar was called it's called now the legendary calendar. It was actually called the legendary calendar in Roman times when it was sort of inherited by the Romans. So the first month used to be March. The last month was December. December was the 10th month. Quintilis used to follow June. Quint means 5. Sex means 6. Sept means 7. So September used to be, it's the 9th month now, it used to be the 7th month. That's why it's called September. October used to be the 8th month. October, octopus, octo. November means 9, and December, decimal, means 10. December used to be the 10th month, now it's the 12th. These they used to all be 30 or 31 days. It used to be pretty even. There were no outliers like February. Okay, that's how things used to be, really long time ago. How many days were in that year? Well, let's take the sum. Let's run this code. 304? There are only 304 days in the year? What's going on? What used to happen in the legendary calendar is once the months ran out, you had another like 50. It was 51 days. Like the calendar didn't change how long it took the Earth to go around the sun. The Earth still took 364.25 days to go around the sun. So once the Romans ran out of calendar, they just sort of waited for 50 days. There was 50 days of no month, of no date, until the new year when the calendar picked up again. That's just how it used to be. So what we're going to do to represent that in list form is we're just going to append something called unnamed and represent it as 51 days. And that should give us all 300 and... we're still short a couple days, awkwardly. I don't know why. That's just sort of how they did it. You can see why they changed it. Their calendar didn't match up. It was sort of as astronomy got better, that motivated them. That gave them ability to realize their calendar was off. And then, and therefore, reason to improve it and get it closer to the actual number of days in the year. This brings us to the Roman Republic's calendar. The Roman Republic, for obvious reasons, was unhappy with the legendary calendar. They certainly didn't like these unnamed months. So the first thing they did was they replaced all those unnamed months at the end of the year with 2 named months at the beginning of the year, January and February. So that's what this code's going to do. First, it's going to get rid of the unnamed month. This is combining 2 things we've learned. We've learned slicing, which is the colon, and we've learned -1, which is a way of getting the last thing on the list. Together, what those are saying is we're taking the index. We're taking everything from the very beginning of the list, because there's no number before the colon, everything from the very beginning of the list up to but not including the last element of the list. Up here we have the list. It goes up to but not including unnamed. So all this first operation is doing is it's taking this stuff, March to December, it's forgetting unnamed, and it's overwriting calendar with this new value. That's the exact same thing except the last thing. Then what we're going to do, having gotten rid of unnamed, we want to add January and February. So we're going to insert in the position 0 of this list, we're going to add January, and in position 1, we're going to add February. And this is going to give us a kind of starting to look familiar calendar. Look, it's got 12 months. They're all pretty much the same, except 2 in the middle, a quintilis and sextilis, are not familiar. They eventually become July and August, but not yet. They weren't that for a while. Additionally, this is kind of weird, instead of a leap day, there was a leap month. And it happened at the end of February, and it was kind of complicated. It changed how long February was. So February got shortened and kind of merged in the intercalaris. All the other months stayed how long they were. They stayed on, roughly 30, 31 days. But February got shortened as intercalaris, as it had to share days with occasionally every couple of years with intercalaris. Intercalaris was about 23, 24 days. It happened every couple of years to correct. Why did we have to correct? Because we had a funny number of days. We had 378 days on some years, the years that had intercalaris, whereas we had, 378 minus 23, that's 350. About 355, which is short of 365 by 10 days. 355 days in the year, the rest of the years. So it was a really uneven calendar. It was much less perfect. But, over time, you run it long enough and you put leap years in at the right places, and it roughly keeps track of the position of the Earth around the sun. It could be worse. That's the old system. This block of code right here is doing quite a bit. Our first line of output is the number of days in every month of the legendary calendar. Then we're going to insert the number of days in January, which got 29. We're going to insert February, only got 28. It got a little, because it got kind of eaten out of, intercalaris eats out of it a little bit. We have intercalaris on this particular year. We've got March, May, quintilis, and October all stay 31 days, which they're still 31 days. But April, June, you see it, sextilis, September, November, and December all get artificially shortened from 30 to, from 30 to 29 days. So these months that you've had your entire life, about half of them used to be shorter. Why? Well, that's just the complex history of the calendar. You can Google this, and there's and Wikipedia has amazing information on why all these things happened, why they made these changes. It's a wild history. The big imperfection of this calendar is going to be that leap month is really awkward. It really, at the end of the day, we could do a better job of tracking the position of the Earth around the sun from year to year. We don't need this dramatic leap month. Let's see if we can get that down to a leap day. What would be involved in getting that month down to a single day that we only have to add every couple of years? This is going to bring us into the Julian calendar. Why is it called the Julian calendar? Why is our familiar calendar, the one that's used all throughout the West, why is it called the Julian? It's named after Julius Caesar. He's the one who introduced it. He shuffled a bunch of days around so that he could get rid of intercalaris, and he was able to in the process lengthened a bunch of the months back to what we're familiar with now. So here's the first thing that's going to happen is we have to get rid of intercalaris. So I'm going to take calendar. Let's see, where's calendar? Here's my last calendar. That's our familiar calendar. I'm going to take calendar, and I'm going to, let me just add it up front. Print calendar, so we can get it all in view. I'm going to run it. I'm going to print calendar. That's the calendar we had, the Roman Republic's calendar. Then I'm going to take this slice of everything up to but not including the second element. That's going to be 0 and 1. So that'll be January and February, but not intercalaris. And then I'm going to take everything from address 3, that's January, February, March, January, February, intercalaris. I'm sorry, 0, January, February, intercalaris. March is the thing at address 3. I'm going to take everything from March to the end. So what we did is we took one slice that goes up to but not including intercalaris, another slice that starts after intercalaris. I'm going to add those two sublists into a new list. And what I'm going to get out is a list that does not, this list here, which is exactly the same as the one above it and the line above it, but it doesn't have intercalaris. So we got rid of intercalaris. Additionally, we're going to do the same thing with the calendar days, our list right here that keeps track of the number of days. Okay, so that's our first change for the Julian calendar. He's also Julius is also going to add a bunch of days. January is going to go up to 31. February is never recovered from intercalaris. It never. It stayed because of the intercalaris. It became 28 and it never bounced back from 28. All the other months get bounced up back to 30 or 31 days, except poor February. So it's unfortunate history that it has to be the shorter one. Goes all the way back to Roman times, pre Julius Caesar Roman times. Okay, so this calendar, when I print this out, that's going to be a really familiar number of days. This looks familiar, and look at that number of days. We have 365 days. That's right. That's correct. That's what we're used to. So the only thing that's not quite right is that the names of the months, 2 of the months are still named weird. The reason for that is Quintilis got renamed July in honor of Julius Caesar. Julius Caesar got a month named after him. That's how great he was, influential he was. But yeah, it makes sense. You introduce a calendar, you should get a month. I think that's fair. Of course, the guy who followed him, Augustus Caesar, thought it was pretty cool also having a month named after him. He didn't make any valuable contributions to the calendar, except change one of the months to give himself a month too. And so we can see here that we're going to change the month at position 6 to July, change the name of the month at position 7 to August, August as in Augustus Caesar, the Caesar to follow Julius. And we're going to get a familiar calendar with 12 months, the right number of days, and the shortest month, that's the minimum of all those calendar days, is going to be 28, just like we expect. So there it is. It was kind of long. We used all these list functions to walk through the entire history of the familiar Julian calendar. In summary, we learned how to make lists of things and access those things. We learned how to change and grow lists, how to transform lists, and we saw the mapping, the metaphor. We really fleshed it out between lists and strings as lists of characters. That's the end of the lesson, so thank you very much.